Okay, welcome back. This is Abdi Muhammad and we're taking math of high school. Tonight's video will be mathematics of angle properties of high school. Then make sure please you catch up with us because math is live and it's very important. So we are going to discuss tonight about angle properties of a polygon. So we're going to learn tonight. So you can catch up with us. Let's see this one tonight. Angle properties of a polygon. This is what we're going to see. Angle properties of a polygon. And we will first see questions from the KLP, then we will go to questions from the likes of Midfamiliar and Spotlight Format and Form 2. This kind of mathematics is very much examinable in KCSE. Guys, we're going to learn this thing as far as the concept of mathematics in high school is concerned. Let's see now the first example, and we are going to start with the sum of interior angles. Sum of interior angles. Sum of interior angles. And the question here is, how are you going to get the sum of interior angles of a polygon? Sum of interior angles of a polygon. Let's see how we are going to get this thing. Okay? And remember, sum of interior angle, NP, you must know that. NP, sum of interior angle, sum of interior angles of a polygon is gotten by 2n minus 4 into 90. This is the formula we'll be using to get the sum of interior angles of a polygon. Then we will also see questions relating to this concept of mathematics. Okay, let's now see. And let's see now first example. Example 1. You are told find the sum of interior angles of each of the following polygons. Like 1A, we have, let's say, a pentagon. Remember, pentagon is a five-sided figure, so let's write this in the bracket 5, which represents the number of sides of a polygon. Then we are going to say solution here, sum of interior angle. Sum of interior angles is equal to 2n minus 4 into 90. Where n, let's say, where n is the number of sides. Where n is the number of sides. Is the number of sides. Then by substituting the value of n here, we're going to say this is what we're having, 2n minus 4 into 90 degrees. So we can say 2 times 5 minus 4 into what? Into 90 degrees. So this will give us 10 minus 4 into 90. So that will give us also 6 in bracket 90. So the answer will be 540 degrees. So this is how you're going to get the sum of interior angles of a pentagon. A pentagon is a five-sided figure, and we will also learn how to construct. We're doing in our next class. Now let's see also B. Let's take this time B. Octagon. Let's see this one. Octagon. Remember, octagon is a sided figure. Octagon is what? 8 sides figure. So number of sides is what? 8. But we know that, we still know that sum of interior angles, is equal to 2n minus 4. 2n minus 4 into 9, where n is 8 this time. Then we're going to say 2 times 8 minus 4 into 90. So this will give us 16 minus 4 into 90. That will be 12 into 90. So it will give us what? 10, 80 degree. That is 12 times 90. So this is how you are going to do during a national exam or in normal exams. This is how we are going to get sum of interior angles of a polygon. But at times what will happen is that you will be given the sum of the interior angles. Then you will be told to find the number of sides or the exterior angle. Let's see like this question. Let's see the application part of this one. Let's see the first one. They say here, let's write this one, example 2. Example 2. The sum of interior angles. The sum of interior angles of a regular polygon. A regular polygon is 1980. 1980. So you are told full stop. Find the number of sides. Find the number of sides of the polygon. Full stop. Now we have the sum of the interior angles, which is 1980 degrees. Then remember, we are going to say solution. Sum of interior angles is equal to 2n minus 4 into 90. Then we can say 2n minus 4 into 90 is equal to 1980. 1980. Then 1980 degrees. Then from there, to simplify it, instead of multiplying 9 times 2n, that is the odd method. We are using the most smart method here to solve this problem. We will divide here 90 degrees, here also 90. Cancel these two, because 90 will go with 90. Cancel these two again. The degree will go with the degree. By 9, 1 by 9 is 2. So we'll have, taking it up, we'll have this one, which is 2n minus 4 is equal to 22. Then take 4 to the other side. 2n is equal to 2 plus 4. Then 2n is equal to 26. 2n is equal to 26. All over 2 then. By 2, 1, by 2, 1, by 2, 1, by 2, 13. n is 13. n is what? n is 13. n is 13. So that is, hence, we're going to say, hence, number of sides is 13. The number of sides is 13. Okay? The number of sides. Let's say the number of sides are 13. Yes. Then for information, we will proceed ahead to see how they also frame during national exam. Let's see a situation where they frame it in a situation like you'll be told to find the number of sides and deduce the name of the polygon. Let's say this is example. This is example 2. You are told, let's say the sum of interior angles. The sum of interior angles of a polygon is 1440 degrees, full stop. Find the number of sides. L or dot is number is short of number of sides. Find the number of sides and hence deduce it is name. Deduce this name. Full stop. What we are going to do here is a solution part. We know that we can say number of sides. Sum of interior angles. Interior angles is equal to 2n minus 4 into 90. Then we can say 2n minus 4 into 90 is equal to 1440 degree. Over 90 again, over 90 cancel. So 2n minus 4 is equal to 16. Take this on to the other side. 2n is equal to 16 plus 4. So let me take it here. 2n is equal to 20 over 2 over 2. N is equal to 10. That is the number of sides. This is what? Hence the name is what? We're going to say hence the name is decagon. Decagon. Because we know that pentagon is 5-sided figure, hexagon is 6-sided figure, heptagon is 7-sided figure, octagon is 8-sided figure, then nonagon is 10-sided figure, then decagon is what? Nonagon is 9-sided figure, decagon is 10-sided figure. Then I'll proceed ahead and see how they also frame the same concept of mathematics in national exam from the Made Familiar, because that book is very helpful. It will help all students to make themselves familiar with the KCSE questions. Then let us see how questions are framed during a national exam from this kind of mathematical concepts. Now let's see, look at this question now. Let's see this one. You are told this is the application part, the application part. Application of the chapter. Application of the chapter. How they frame during a national exam. You are told the size of interior angle. Example 1. The size of interior angle. The size of interior angle of a regular polygon. Of a regular polygon. Of a regular polygon is 156 degree. Is 156 degree full stop. Find the number of sides of the polygon. You're told find the number of sides of the polygon. Sides of the polygon. Now, solution to this problem. Number of sides of a polygon is equal to 360 over exterior angle. This is the formula of getting number of sides of a polygon, 360 divided by the exterior angle. Go back to the question and read. You are told the size of interior angles, or the size of interior angle of a regular polygon is 156 degree. Find the number of sides of the polygon. We know that the number of sides of any polygon is gotten by 360 divided by the exterior angle. But here we have the interior. Bear in mind that interior angle plus exterior angle is equal to 180 degree again. So far we have the interior angle, we can get the exterior angle. We can say exterior angle, therefore, exterior angle is equal to, take this on the other side, 180 degree minus interior angle. Interior angle. Then we can say the exterior angle, therefore, exterior angle is equal to 180 degree minus 156 degree. So that will give us what? 24 degree. But, inform them, but, number of sides. As we have said, the number of sides is equal to the number of sides of a polygon. Of any polygon is equal to 360 divided by our exterior angle. That will give us 360 degree divided by 24 degree. Degree and degree will cancel by 24, 1 by 24, 15. So it is 10 sides. So that's how you are going to answer in case you are asked such a question in the national exam. Then we will proceed ahead with the questions of the familiar and solve them. Let's say example 2. Example 2. You are told the size of each interior angle. The size of each interior angle of a regular polygon of a regular polygon is 5 times. 5 times is 5 times the size of the exterior angle. The size of the exterior angle. First, find the number of sides. Find the number. Find the number of sides. Find the number of sides of the polygon. Full stop. Look at this question. The size of each interior angle of a regular polygon is 5 times the size of the exterior angle. Find the number of sides. Let's write here solution bar. Let's come to the solution. Let's say this is the interior angle, and here we have the exterior angle. The exterior angle. Then we say the size of each interior angle of a regular polygon is 5 times. Let the exterior angle be x. This will be 5x, 5 times the exterior. But we know that exterior plus interior is equal to what? 180. So we can say 5x plus x is equal to 180. Then 6x therefore is equal to 180. Then to get the value of x, divide both sides by 6, cancel. X is equal to that. This is what? This is the exterior angle. Number of sides. Number of sides is equal to 360 degree divided by exterior. Number of sides, therefore, number of sides will be 360 degree divided by that degree cancel. Then that is 12. That's what? 12. So this is how we are going to tackle questions from this angle properties of Form 1. For your information, in our next class, we will proceed and see angle properties of a circle in Form 2. That's where angles concepts are very, very much concentrated. And God willing, I'll try my best to simplify it for you before we proceed to the 3 concepts that are found in the KBO Form 3 Mathematics. Please make sure you don't forget to subscribe this YouTube channel of us. You can leave your comments in the comment box. In the events where you have something to supplement, you're also welcome. I wish you the best. Take advantage of this class. I wish you the best.